But to kick things off, I just want to welcome everybody to another live cyber training workshop. Today, we're going to be talking about AWS IAM Privilege Escalation, and we're going to talk about it from two very different perspectives. The first perspective is going to be the attack perspective. So we're actually going to walk through a live attack, a live IAM Privesk. And then after that, we're going to talk about defenses. Manuel's going to demonstrate how we can approach defending our AWS and cloud environments from this type of threat. And he's actually going to jump into a console and show the result of the attack that I perform in the first half of the presentation. So I think it's going to be a really fun one. If this is your first time attending, which I believe, like, would you say 80% or so of people are attending for the first time, I think you're going to enjoy it. I think you're going to have a good time. So sit back, relax, and enjoy the show. And then if you are a Cybr member, you'll also be able to launch the lab as I'm doing it as well. So you can either just watch me do it or you can follow along the attack as well. Either or is good. So as we kick off here, just some frequently asked questions. I know these questions are going to pop up, so I'm going to get ahead of them. The first one is that, yes, this is going to be recorded and it will be sent out about 24 hours. I say 24 hours, might be a little bit more, a little bit less, but by tomorrow, you should get a link in your inbox with the actual video presentation here. If you don't receive it, then send me a DM on LinkedIn or on Discord, and I'll be able to send it to you directly because sometimes email just doesn't deliver super great. And then in that same email, I'm also going to send out the slides that you're seeing right now that will be available for download. And as I'm saying that, if you don't mind giving me a thumbs up, there's a way to react in the webinar software there. If you can give me a thumbs up if you're able to see this, my screen here, the slides, I just want to make sure that everybody's able to see it and that we're all good to go. I see one thumbs up, 2, 3. Okay, perfect. Thank you. Appreciate it. And then also the next thing I want to mention is that you're able to ask questions through the webinar software. There's a Q&A section. You can ask it at any point in time. You don't have to wait for the very end. You can ask it at any point. It's not going to interrupt anything. It's not going to display to everyone right away. So if you have a question that pops in your head, you want to ask it, go ahead and ask it right away. And then either myself or Manuel will be able to look at the questions, and we will either answer them right away or we may wait to the very end, depending on the question. So if we don't get to your question at the moment, then don't worry, we'll get to it towards the end. And then, as I was saying earlier, there's something going on with Google Slides today. Like, I'm pressing the next arrow and it's just refusing to go. So bear with us on the technical difficulties. We've used the same software for multiple times now. I don't know why it's happening today, but Google's just having a bad day, I think. Anyway, so we're in today's session, we're going to first talk about our introductions, or start with our introductions, I should say. So I'm going to introduce myself. Manuel's going to introduce himself so you know who we are, what our background is. Then we're going to go straight into it by first explaining what privilege escalations are. I know most of you attending today are somewhat familiar with it. Some of you are very familiar with it. But for those of us that are not as familiar with cloud-based privilege escalations, we're going to give a quick background on that. Then I'm going to hand it off to Manuel, and he's going to give us a real-world attack example and scenario that actually happened, I believe, in 2014. So not that long ago, and there's been some more recent ones since then. But in that particular case, it's a real-world attack that involved privilege escalations in Amazon Web Services. Then we'll dive into that hands-on demo that I was talking about earlier. Then the hands-on demo for defense before we talk about CodeShield and Cybr, our respective services. And then we'll open it up to live Q&A. So if there's any questions we haven't answered yet, or if you held your question to the very end, then we'll be sure to spend some time and answer those then. So on that note, Manuel, if you would like to start us off with your introduction.
Sure. Hey, everyone. So for those who don't know me, I'm Manuel. I'm actually the CTO and co-founder of CodeShield. Split, thanks. I have like more than 5 years of experience developing in AWS and also analyzing AWS. So we built basically a software as a service solution that attacks privilege escalation in AWS. And this solution itself is running on AWS. So I'm developing in AWS as well. And you can be assured I know all the issues that you have as a developer when you use AWS, not only from like a producer side. Anyways, my background is I come from like a static and dynamic analysis background. I was doing research in that topic that was specifically targeted towards detecting like code vulnerabilities in Java applications. And regarding my hobbies, I'm basically a drummer. I do music, play drums in a band, and I'm a house owner. And that's not necessarily like a hobby of mine, but since I bought this rather old house like 2 years back, I'm still putting a lot of my free time into renovating the house, right? Sometimes it's fun, but most of the time it's just work. And I'm living next to Frankfurt, Germany.
It's so funny you mentioned that. My wife and I have been renovating our dining room, and I thought, oh, this is going to take a couple weeks. I'm pretty sure it's been a month now, and we're still not anywhere near done. So, the house projects are definitely very time consuming.
Yeah, for
So I
me
can
it
relate.
goes more towards the years, basically. Thinking you can do it in a year, then it takes 3 is more like I was working for me.
Where it gets to the point where you're like, I should have hired a professional that actually knows what they're doing versus try to do it myself. Yeah. Anyway, so thanks for your introduction, Manuel. Moving on to mine. I'm Christophe Limpalair. It's very nice to meet you if we haven't met yet. I'm the founder and trainer at Cybr, cybr.com, where we do AWS cloud security training. I have over 8 years of AWS experience. So just like our co-host today, I have felt your pain if you're working or developing in AWS. It's a great platform, fantastic platform, very powerful, sometimes extremely frustrating as well. And so that's why we host some of these live training sessions so that we can help share some of our learning experiences and hopefully make your experience a little bit smoother. But my background actually before AWS was primarily in web development. So I really am a developer at heart. But then I switched over to, I say switched over, they sometimes go hand in hand, right? But looking at the cloud, how to develop and deploy onto the cloud, more architecture style, more cloud security, things like that. I live in Colorado and I love hiking and skiing. So if you're ever in the state of Colorado or near Denver, please shoot me a DM. I'd love to go hiking, or if it's the right season, go skiing with you. Okay, so that's it for introductions. Like I said, we're going to keep that really brief so we can get into the meat of things and start by talking about what are privilege escalations in case you're not familiar with it. In very simple terms, a privesc, short for privilege escalation, is really just an attacker being able to go from a lower level privilege to a higher level privilege. And that could mean a number of different things. But in AWS, when we're talking about AWS specific privilege escalations, we're typically talking about an attacker having found a way into your environments through maybe a user, like an IAM user or single sign-on user, through an IAM role, or maybe even through a resource like an EC2 resource, a container, web application, things like that. But when they first get that access, their access is very limited. They may not be able to do a whole lot or nothing that would make it worth their time, right? They're probably trying to get money or do something with your resources that would negatively affect you, but with their current access, they're not really able to do that. So instead, they want to look for a path, a privilege escalation path that would enable them to elevate those permissions from where they currently are to something more substantial, something that can give them some sort of access to your data, to other resources, and things of that nature. But to be clear, it doesn't necessarily just mean that they immediately are able to escalate to administrative privileges. I think a lot of times that's what people think, right? Oh, an attacker got very limited privileges. They found a way to get admin level privileges to completely compromise your account and you're screwed. Well, that's not necessarily the case, right? You could have much lower level privilege escalations where they don't even need to have access to admin level privileges and or permissions, because even without those admin rights, they could still do things like launch really big EC2 instances for crypto mining. That's something we've been seeing a lot the last few years, especially when crypto gets to its height. We see a lot more activities like this. Or they could try to exfiltrate sensitive data. Again, another very common use case. You've probably heard of this in the news with Amazon S3 data leaks. Some XYZ corporation had an S3 data leak, and now they are fined, or it's costing them hundreds of millions of dollars in reparations, fines, etc. Or it could be a database. Maybe somebody gets access to an otherwise protected database. They could get access to code, and maybe there's secrets stored in that code, or maybe it's proprietary code, things like that. There's a whole host of things they can do even without admin rights. And one of the examples that we're going to give today in our demo is going to be accessing secrets that are stored in the AWS service called Secrets Manager. I just picked that service because that's literally what it does. It stores secrets, but it could be something else that also contains something important. And so on and so forth. That's just three large examples of what you can do when you're able to escalate privileges, even without necessarily having access to admin level privileges. So as I mentioned at the very beginning there, Manuel's actually brought a real world example of impact so that you know that we're not just saying this theoretically. This is actually happening in the real world. This is being exploited, and it's a very real threat. So on that note, I'm going to hand it over to you, Manuel, if you want to take over screen share.
Oh, I was muted, but you can see my screen, right?
There we go. Yep, we can see it now and hear you.
Okay, perfect. Okay, so the rebuild example I brought today was a hack in 2014 against the CodeSpaces company. And there are a lot of actual hacks in the wild out there that are caused by privilege escalation. But I like this one a lot because like the impact of the hack is so tremendous. So basically within 12 hours, like CodeSpaces went from a viable business to like bankruptcy because one hacker got access to their account and was able to drop all their databases and backups containing all customer data. So they had basically no chance to come back to business because of that. And I wanted to go a little bit over how exactly this hack happened, like what the steps were, because I think it's also very interesting to note that these attacks usually like either are very, very simple. So we got attacks we get in against AWS. I mean, sometimes it's just like an open bucket that can be publicly accessed from everywhere, and you don't need much more than the name of the bucket. But oftentimes attacks are very complex and contain like multiple steps and also multiple vulnerabilities on the way that where something needs to go wrong, that anything can happen. And in this case, basically, the attack started by a DDoS attack against the website of CodeSpaces. So this DDoS attack was just a distraction, but it was very fruitful because like CodeSpaces was very, very heavily working on defending against the DDoS attack, getting the website back up and letting the servers like do their work again. But in the meantime, the attacker basically used the distraction to log into the EC2 control panel with some stolen credentials. So it's not clear how exactly the attacker got these stolen credentials. Might be by phishing attack, or maybe he just like found it in an open source repository or something. That also happens. But I would guess it's a phishing attack because that's like basically kind of the most usual thing how hacks start in the real world. And having access to the EC2 control panel, the attacker was basically able to then do like a privilege escalation attack to gain persistence to the account. That means he basically, from the EC2 instance, he had the credentials from, was able to create like a user in the account, attach it like a policy that would be probably the admin access policy, and then create an access key for that user. So in the end, he basically could use the access key to do actions with that user he just created. That's basically the privilege escalation. And then he raised extortion demands against CodeSpaces. So at that point, CodeSpaces was aware that someone introduced, was in their system basically. And that's when they basically started to change the keys for the EC2 instances. Unfortunately, that was too late because the attacker could already create persistence to the account. And since he noticed that CodeSpaces was actually defending against this attack by deleting, like changing the EC2 keys, he just like deleted all the S3 buckets in the account containing the backups and of the databases and all databases as well. So in the end, CodeSpaces basically had no customer data as well anymore. And what I think I forgot to say, like CodeSpaces, they were a competitor of GitHub. So their business really was to host like code repositories for developing companies. And you can imagine if all these code repositories are gone, that's also huge damage for the customers. And therefore they couldn't, CodeSpace basically couldn't come back from the damaged payments they had to do. So as I already mentioned, like I think this is like huge impact. It doesn't necessarily have to be that huge of an impact all the time. But I think there are different things that went wrong here. First of all, we don't know about the credentials, but if these were like username and password credentials, then you would ask like, why don't you use like MFA that would secure you versus that? But then on the other hand, if it was an access key, these usually don't have MFA enabled. So if it was like a programmer's access key, then using MFA wouldn't help here a lot. Then on also there are questions like or design flaws in their system. If you think about it, why do they have like the database with their customer data and the backups in the same AWS account? If you think about it, the attacker was able to get persistence to one account and they managed to drop all the data. So at least one thing you can come up with to defend against this as well would be making sure that your backups are not the same account. I think that's just like a best practice we should all just like keep in mind, right? Because it's such a simple measurement, but it can have such a huge effect, right? And of course, last but not least, the question is why this EC2 instance was able to do like a privilege escalation of that manner to gain like admin access to the account. But I think, Christophe, it makes sense if you now show a little bit more like in practice how such privilege escalation would work.
Absolutely. And there are also, we've created a couple of labs that are specific to EC2, and you've got issues like remote command execution, things like that. Even with IMDS v2, right? IMDS v1 has some
Mm,
issues. And so they've upgraded to IMDS v2 if you're familiar with what that means. There's
mm,
still some potential attack paths through that.
mm,
And so we're actually launching a lab specific to that soon so
mm,
that people can see, hey, just because I've upgraded to IMDS v2, that doesn't mean that I'm safe, I'm secure. There are some other things that you should also take into account. But so in today's demonstration, we're not going to be dealing with any EC2s. Instead, we're going to take a couple of steps back. And I know you showed or you mentioned the create user, attach user policy, and I think it was create access key. And those are three really important IAM actions to keep an eye on because they can lead to privilege escalations. In today's demonstration, I'm going to be talking about a different one, which is IAM put role policy. So let me go ahead and share my screen again here. And then I'm just going to set the scene, set the stage with a quick scenario, kind of give you the background of what's going on in this lab environment. And then we'll jump into the actual lab environment and execute it. Can you give me a thumbs up to make sure you can see my screen again, my slideshow?
So I can definitely see it.
Okay, cool. I'm seeing a couple thumbs up. Thank you. I appreciate it. There's a link there at the bottom. If you're a Cybr member and you're logged into the platform, you can actually go to that link and it will pull up the exact lab that I'm going to be demonstrating, basically step by step here. So if you want to follow along and actually do the lab as I'm doing it, I would recommend spinning it up now because it might take a couple of minutes to spin up. If not, then just feel free to watch me do it. No worries at all. You'll see exactly what they would get access to. So in our scenario today, we're going to pretend like we have an organization and I'm part of a team. I'm a developer working on a team and I need access to the Amazon S3 service, which is where you can store all kinds of data objects. It could be data for personal reasons, all the way to large amounts of data sets for your applications, for machine learning, things like that. So as a developer, my applications need access to an Amazon S3 bucket and I get access to it by assuming what's called an IAM role. And because I'll need to be able to create more buckets along the way, or maybe even change settings on those buckets without having to constantly go to the security team or constantly having to go to my manager, which, if you've been in that situation, can be very, very annoying. The manager realized, you know what? I can just give you a little bit more permissions. I'll give you the ability to upload your own IAM policies. And there are ways of doing that very securely. You can do this in a secure fashion, but unfortunately, the manager misconfigured this IAM put role policy permission, which means that I'm able to escalate my privileges. And I'm saying I as the developer because this type of scenario can be exploited either by an external threat actor. So like Manuel was just talking about, somebody maybe gets access to your access keys or something that you left behind. Maybe they phished you, or it could even be exploited by an internal threat actor. Maybe I'm a disgruntled employee. I didn't get that raise, whatever. I'm having a bad day. I don't know. In either case, this type of scenario can be exploited both internally and externally. But what we're seeing here on this diagram is the expected use case. If I'm a great employee, I'm not malicious, then I can just assume the role. I can upload a different policy to this role as needed in order to create or modify buckets again as needed. So that's the expected behavior. Unfortunately, because it was misconfigured, because the manager did not add the correct restrictions in there, and some of the things we'll talk about in the defense section, because of that, either myself or the external threat actor would be able to upload all sorts of different policies to this role and basically change from just being able to access Amazon S3 to being able to access other types of services like Secrets Manager. I'm only showing Secrets Manager here, but in the worst of cases, it could involve all kinds of services. It could be EC2, it could be RDS, which is one of their database managed services. I'm just showing Secrets Manager here, but keep that in mind that the impact could be even wider than that. And so this is the threat use case. This is what the manager hadn't thought of. And when they gave me those permissions, they thought, you know what, it'll be fine. We're good to go. When in reality, they actually opened up a fairly significant, actually a massive, potentially privilege escalation path. And that's the one that we're going to be demonstrating here in this presentation. So on that note, let me go ahead and switch out of the presentation and I'll switch over to the lab that we'll be taking a look at today. So like I said before, if you wanted to go to that link, or if you're a Cybr member, you can go to this AWS IAM Privilege Escalation Labs course. Even if you're not a Cybr member, the content on this page is free. You just won't be able to launch the lab. So if you want to pull it up and be able to read through the lessons, all these are completely free. I'm pretty sure you don't even need to register. You can just go on there and take a look at it. So if you're interested, check it out. And then right below the actual lab CTF page, there's going to be a solution page. So that's the one that I'm going to switch to because I've already launched the lab in a separate window that we can't see here. So pretend that I already clicked on Start Lab. I've already received my credentials and I'm already past the first step, which was to configure my credentials. So I typed in AWS configure and then I set a profile of lab. I passed in the access keys that were provided by the Cybr Lab platform. And now I can go ahead and do STS get caller identity, which would be probably one of the first steps that an attacker would take just to figure out, hey, I got these credentials. Let's make sure they're valid credentials. And beyond that, let's also just get a lay of the land. Let's figure out who I am. Am I a user? Am I a role? What account ID am I in? Things like that. So this is kind of the who am I of the AWS world. And that would be a really good starting point to figure out, okay, now I'm a user and I can see that from this Amazon resource name. I'm in this account right here. And my user or username is Prevesk Demo Support Mike. So that gives me a good starting point. Now, beyond that, as an attacker, I would need to perform some enumeration to figure out how this environment is configured, especially from a permissions perspective. If I'm the developer that's already part of the organization, I probably already know this information. But if I'm an outsider, I wouldn't, right? I would come into this as a black box. I would have blinders on. So I would need to run some basic commands just to get an idea of what's going on. So we'll kind of walk through the steps fairly quickly here to demonstrate how that might go. So the first command that I might run is list groups for user. And then I'll pass in my username that I just got from the prior command. So we're going to pass in this username right here. And then I'll pass in my profile of lab. And by doing that, it tells me that I am indeed part of an IAM group, and the group name is called Prevesk Demo Support. The reason that that's useful and that it's important is because now I can retrieve the policies for this group. And we'll see why that's important in just a second, because now I can type in this command of AWS IAM list group policies for the group name that we just retrieved. So I'll pass that in. And by the way, if I'm going a little bit fast, it's just because we don't have that much time to go through and explain everything in depth. But if you have any questions about what I'm doing, if you're getting lost about some of these steps, please go ahead and ask the questions. Like I said before, you don't have to hold questions until the very end. You can go ahead and ask them now. So if If I need to clarify on any topics, then feel free to go ahead and ask now. So
Uh,
now I just,
Christoph,
yeah, go ahead.
could you maybe like restart your sharing? Someone's telling that it's frozen.
Oh, okay. Let me see. Oh, you know what? I think I did this again. Thank you for stopping me. I appreciate it. I did this one time before where it only showed one part of the window and that people couldn't actually see the terminal that I was
The
stepping through.
terminal wasn't, yeah, it was, but now I
Okay. Oh
can
shoot.
see
Okay.
it's
All
there.
right. So let me step back just a little bit. That will make a lot more sense. Thank you for stopping me. That that is not at all what I was going for. Okay. So let's take a couple of steps back. I was showing the walkthrough through here, but essentially I'm doing the same thing split screen. So give me a thumbs up if you're able to see both the browser window and the terminal, please. Okay, perfect. Thank you. Okay, great. So again, just to get started, right, when I went through and started the lab here, I got some credentials. I put in the credentials through the AWS CLI, and I configured those credentials through this command here. Then once I did that, then I started my enumeration. So first I ran AWS STS get caller identity with my profile of lab to use these credentials that I received from the lab environment. From there, I get a user ID. I get the account ID, which is the AWS account ID. And then I get what's called an Amazon resource name, which is a unique identifier. And in this case, that username tells me that I, again, am in this account and my username is Privesk Demo Support Mike. So that tells me that I'm an IAM user. And now I can try to enumerate information about that user. So I ran the command list groups for user, passing in the username. And that told me that I was part of this Privesk Demo Support group. And then using that Privesk Demo Support group, I was able to enumerate the policies that are attached to that group. And in AWS, if you're not super familiar with it, policies are what dictate what you can do. They say, yes, you're allowed to take this action, or no, you're not allowed to take this action. So policies are really important, which is why I'm listing out the policy names here so that then I can run this command of AWS IAM list groups for user, and then I can pass in the username. Wait, nope, sorry, I already did that. Let's scroll down. I was going to say that doesn't sound right. Then we can do AWS IAM get group policy for the group name. So we've got the group name up here, and then we've got the policy name down here. So we can also do -- policy name. And I'm just copy pasting because I cannot multitask. If I try to multitask, we're going to be fixing typos the entire time I'm going through this demo, and we don't want that. So what I'm doing now is because I've listed the policy name up here, now I can actually retrieve get that group policy by passing in the group name and the policy name. So I'll do that real quick. And I'll just kind of scroll through so we can get an idea of what's going on. And then I'll go back up so we can explain what's happening and what's important to understand from this policy. So this is the IAM policy that's attached to my group, which means this is the policy that I inherit as that Mike support user. The two ones that I want you to care about right now for the sake of time are going to be the action of put role policy, which is what I was talking about before that we're going to exploit. And the other one is going to be the assume role action. So in this case, it's saying that I'm able to assume this role right here. And I'm also allowed to put role policies on that very same role. So I can modify what policies are associated with that role, and then I can assume the role. So as an attacker, if I saw this, I would go, okay, great. Let's go ahead and try to assume that role, which is going to be the next step. So if we scroll down a little bit, we could also get more information about the support role. So I'll go ahead and do that now, because since we see the name of the role right here, we can filter for that specifically. So I'll do profile lab. We'll see the ARN value of this role right here, which matches what we had in the IAM policy. So that's helpful. Then we could do list role policies for the role name of support role. And again, I'm going through this kind of fast because we don't have a whole lot of time. But if you need any clarification, please don't hesitate to ask. And then we will do role name. I actually think I have a typo here in this write-up. I just noticed that. So we'd want to do support role. I'm pretty sure it's case sensitive, so you want to make sure that's right. And then we'll pass in this policy name right here. Now, the reason I'm doing this, in case you're wondering, is because the role already has certain types of access. it has access to the Amazon S3 service and different buckets within that service. If you think back to that diagram that we're looking at before, we have S3 list bucket access, S3 get object, things like that. So this is properly configured as the role for me to assume to access Amazon S3. That's what we expected. That's what we wanted. To validate that and to verify that, I'm going to go ahead and assume this role. So what we'll do is we'll pass in the role ARN that I received earlier, which was right here. So I'm actually going to assume that role now. And then we'll also pass in a role session name. And I'll just do lab demo and then profile lab. So we get back credentials to assume this role. So now I can go ahead and configure my CLI for that. So we'll do AWS configure profile support role. We'll pass in the access key ID for that guy. Then we'll pass in the secret access key. We'll do a default region of US East 1. And then I just like doing JSON. So I'll go ahead and do that. Now with roles, we get session tokens, which are temporary credentials. So we also need to pass that in. So we'll do AWS configure set AWS session token. I'll paste in my token here. And then profile of support role. And now I can rerun that STS get caller identity with my profile of support role. And we can see that we're no longer authenticated as a user. We are now authenticated as the role support role with the session name of lab demo. So now that we've assumed that role, we can run S3ls to list out the different buckets that are in this environment. And we'll see that I have access to Amazon S3. So that's totally normal. That's what's expected. And I'm kind of setting the stage. I know you're probably like, wait, where's the PrivEsc? But I'm setting the stage, right? This is looking right. And if I try to list out secrets in Secrets Manager, I get access denied because I'm not supposed to, as a developer, in this case, I'm not supposed to be able to access secrets that are stored in Secrets Manager. But everything's about to change because I'm about to exploit the IAM put role policy. And I'm going to upload my own policy to this role that I've already created. And you can copy and paste it from the notes in the lab here. But I've already created it here. So I can do cat policy.json. It's been created in this directory. And it's an all access policy. So for all intents and purposes, this is a full administrative policy that can now upload, or try to at least upload, to my role. And the way that we can do that is by typing in AWS IAM put role policy. Then we'll pass in the role name. See, I told you, I don't know why I'm trying to type this out. I can't type and talk at the same time. It's a problem. So we'll do support role policy name, and we'll just name this policy name secret access. And then we'll pass in a policy document, and we'll do file policy. Is that right? Nope. Policy.json. You would think I would have had enough practice to be able to do this by now, but apparently it's not the case. We'll pass in our profile of lab this time because the user has access to update the role. The role doesn't have access to update itself. So we're using the user credentials right now. We'll do put role name, support role, policy name, secret access, and then pass in that policy document of policy.json. We don't get anything back, which is actually a good sign in this case, because now using the role credentials, we can go ahead and try to list secrets that are stored in Secrets Manager. And bam, just like that, you were able to give yourself access to list secrets that are stored in the entire AWS account, or that entire AWS account. So this is a secret I was not supposed to be able to access originally. Maybe it was for a different development team. Maybe it was for a solutions architect team. Whatever the case may be, I now have access to the secret that I should never have been able to access, simply because my manager gave me IAM put role policy access. It's almost a one-liner, right? It's not exactly a one-liner because JSON policies are more than one line, but literally by just adding that one action, you can create this very dangerous path for potential privilege escalation. Let's see if there's anything else. Oh yeah. So if you're going through the lab, I won't do it now. I guess I can go ahead and retrieve the actual secret itself if you want to see that. But it's base 64 encoded. So just as a surprise, I'm not going to show you the base 64 decoded version. If you want to complete it, you can absolutely do that if you'd like. But just for suspense, I'll retrieve it, but we won't look at the actual base 64. So here's the vault password, and then here's the base 64 encoded version of that secret string. And so if I'm an external threat actor and I see this and I retrieve this and say it's the secret for a database or for an API, I automatically here have access to that database or to that API.
Yeah, I think that's very important to note here, right? This is like the scenario you came up with, that you have a flag in it, like the secret, but actually you gave that role like admin access, right? So you could do much more as an attacker than just extracting the secret. You could use it, of course, to decrypt data in a data store, but you could also like delete users to make sure no one is able to access the account, even delete the whole account or run a crypto miner or whatever, right? So everything would be possible with these permissions.
You could. Now, when I said at the very beginning, if you remember, and then I'll hand it over to you, Manuel, but in the very beginning, when I mentioned you can do this safely and securely, so there are very many cases where developers need a little bit of flexibility in the account. They need to be able to modify their permissions on the fly, but within reason, right? Not like what you described, where all of a sudden they can completely own the entire account. That's not what we want. Most of the time, unless it's their own private development account, most of the time you don't want to give developers that full admin access. So if you need to give them that flexibility, but not full admin access, you can do things like using boundary permissions. And so that way, for them to be able to put this type of policy, they would also have to put a boundary policy on top of it. And that boundary policy would prevent them from being able to create users, delete users, create access keys, even if they upload that policy that I created here. So even if they upload the full admin policy, you can still restrict that by denying access to it explicitly. And in that case, if I had a boundary that prevented me from accessing secrets manager, excuse me, in that case, even if I upload this full admin policy, still wouldn't be able to do it. So it's possible to do safely. It's just my manager didn't, he rushed through it, or maybe he didn't know about it. And so unfortunately, in this case, I would actually have full admin access. Yeah. Any questions? Questions, thoughts? So one of the questions that we have here is, let me go ahead and project this. They're asking if with put role policy, whether that should go through an approval of the manager. Can we embed that in a workflow? The short answer is you could do that, absolutely. So maybe you have a security team that typically hands out permissions like that. Maybe you have what they call a vending machine for permissions, where if you need to assume a certain type of role, maybe it's a higher privilege role, you have to go through an approval process. So you have to have maybe 2 people that would approve that, depending on how severe of a role it is. You could do that. Or like I was saying earlier, I would recommend looking into something like boundary permissions, because then as the security team, I can enforce boundaries on the manager. And then the manager, if they try to give me more privileges than they're supposed to, they wouldn't be able to do that because I'm enforcing boundaries on them. And then if that manager who has boundaries has to provide access to the developer, me, then in that case, they would also enforce boundaries on the developer. So it kind of trickles down. So there are different ways to think about it. You can have that vending machine type of approach and process. Plus, on top of that, you can also enforce things like boundaries where they're physically not capable of granting more access than what they've been given by the security team.
Yeah, maybe that fits very well to the next question, which is like, are boundaries equal to SCPs? So SCPs are service control policies in AWS. They are not the same. They are pretty similar. And SCPs so with both, you're basically capping the maximum permissions an identity can have, right? But an SCP applies to the whole account. So you can say like for all identities in this account, no one should ever be able to delete this account or something like that. And a permission boundary is a similar concept, but you attach it to an identity, so to a user or role, not to the account. So for example, you could say every time I create a user, it needs to have this permission boundary, and the permission boundary restricts the user to, for example, delete other users or something like that, or restricts it in the sense that it can create roles if it needs to be an IAM manager, but not roles that have admin access in the end and that have a permission boundary as well, right? So there are a lot of things you can do with these if you use the conditions, right? And usually you have to make sure for all these actions that create identities, like create role or create user, that you add the condition that these identities can only be created with a permission boundary that you defined beforehand, right? So then you can make sure that there's no one who can do privilege escalation in that scenario just by creating a user and attaching it. The admin access policy won't work because you can attach the access admin policy, but you also have to attach the permission boundary that which then caps the permissions of the admin access admin policy. I hope that makes sense.
Yeah, that was a really good explanation on my end. If not, if we need any clarifications, go ahead and ask. These are fantastic questions. Thank you for asking. All right. Well, as we wait for more questions to come in, if you want to take back over, Manuel, I believe. Let's see. Did I have anything else to add? Did you want to add anything else to that? I think we're good, right?
Yes. I think so as well. So I think there might be some smaller details that I might add, because like what we did is like with CodeShield, this is basically our software as a service solution which analyzes AWS for privilege escalation mainly, but generally for IAM flaws. I will now show like the scan we did on Christophe's account, right? So we will see the same attack again, but this time from defense perspective. So you would scan your account basically in the period, like every week, after every commit, every day, which depends on your how you configure it basically. But generally speaking, you would analyze your account and you would find that you have vulnerability that allows privilege escalation before it's exploited, right? So this happens before the attack happens. It's not like incident response, but it's like a vulnerability scanner for code that you can see you have vulnerabilities in your code. And we actually scanned the account that Christophe just showed us. And this basically like just the dashboard that gives you some overview about what we found in this account. It's a pretty small account. It has like 19 resources we start the analysis from, where we try to do privilege escalation from. We found like 19 attack scenarios. These involve privilege escalation from 2 of these resources. And we classify the privilege escalations, so the impact of these attacks basically. So 11 of these attacks would allow the attacker to gain admin access, like 7 allow to gain credential access, which would be access to the secrets manager. And then there are others like you get access to data storage, or you can write or read to a data storage. What else do we see here? Like maybe this one is very known to us, right? This is the policy that was able to conduct the issue. That is one of the top 3 root causes. The other one would be the IAM full access policy. And we can see that like 18 of these attacks are all coming from these AWS reserved SSO role, which is not so interesting for us today. But one is actually coming from the priv ask demo support mic user. This is the one that Christophe showed us, right? So let's have a look at this. So basically we see now here the list of escalations, and I already marked the one we want to talk about as a favorite here. This is starting from the user, priv ask demo support mic. He can abuse the permission put role policy, which exactly what we saw in Christophe's explanation, to gain credential access and to gain data storage read access, right? So he would be able to gain like access to like 2 credential resources and 4 data storage resources. So if we look now at the actual attack scenario, so this is how it looks in our front end basically. This is the attack path that exactly explains how the attack should work. Do we have a question which we should put in right now?
For questions, let's go ahead and keep going, and then we can answer questions here in a minute.
Okay, makes sense. So what we can see here basically is a step-by-step description of the attack, right? And the attack works like this. Someone who has access to this user, as Christophe mentioned, might be stolen credentials or might be an insider, has basically, the user has a policy attached, and this policy allows us to conduct IAM put role policy, right? And we can have double check. Here is basically the IAM put role policy. It can be conducted against a support role, and it can only be conducted from like the PrivS demo support mic. So that's basically conductable. And we in our tool make sure that these actions are evaluated, right? We really look, are these possible after evaluating the conditions, the explicit denies, the implicit denies, resource-based policies, permission boundaries, and so on. And after doing this, we basically see, okay, you could use these actions against the support role, right? So the attack would be just attach like a policy to the support role. This is written in the right. Now the attacker can put a policy to the support role. For example, a policy that looks like this one. So this is a generated one. If you look at this, this basically stars, exactly what Christophe showed us, right? So now our tool simulated, okay, this is the most access we can give with put role policy. So let's do this, do the policy evaluation, and look what we can access after we did the attack. And now we see we actually gained access to the get secret value as secrets manager and get secrets manager list secrets. And these both apply basically to this secret. And Christophe, right, that was the secret you were showing in your attack, right? So
Exactly.
we now found the exact same attack basically, but before it was conducted from our tool side. And we can also have a look at the other classification, this one, which shows us we also get like S3 get object to these 3 buckets after conducting the attack. And we classify this impact that you can get like credentials access, data storage, read access, to allow you to basically to better prioritize how important it is to fix these scenarios, right? Here we see a lot of scenarios that just give us like plain admin access or something like that. That's obviously the thing you want to look at first. But this gives you really in-depth information, what exactly will be accessible after you conducted the privilege escalation. Okay, so much towards the tech path then, and the impact basically, maybe a little bit regarding the fix recommendation, right? For each scenario, we also describe how you should fix it. And what's written here is basically make sure that the user mic really needs like put role policy. If not, just remove it from the managed policy and you're good to go. That's always the simplest thing you could do, right? It's plain over permission. You don't need it, just remove it. But of course, sometimes you need these permissions. So if you need it, then make sure to modify basically this policy so that put role policy can only be conducted on necessary tasks, especially not the support role. Why not the support role? Because the support role, as Christophe showed as well, can be assumed by the user, right? So if you allow this, but to a different role, you might be able to give someone admin access, but you cannot assume that role, and thereby you can at least not give yourself admin access. So that might be the thing you want to do, because you want to be a manager, give permissions to someone, but not be able to give yourself more permissions. Anyway, what's missing here, and usually this should be written here, I'm not sure why it's not here, but I have to look this up. The alternative would be exactly what Christophe mentioned, that if none of these both suit your scenario, the best thing to do is here add like a permissions boundary. So we can see like this user already has like a permissions boundary, and as I already mentioned, as this caps the effective permissions you can do to what is written in this permission boundary. So for example, put role policy should be allowed, assume role should be allowed, and so on and so on. But you can add like the permissions boundary to the support role. So does it have one? Role permission boundary. Let's have a look. And this allows to access the secret manager. So if you want to restrict this, you would need to add like permission boundary that makes sure that the support role has the minimum possible permissions that you want it to have. So that someone like the support Mike can give it a policy that does whatever it wants, but it can never get more permissions than the permission boundary of that role allows, right? That would be also a possibility to fix this. I'm not sure if you have mentioned this, Christophe. Of course, this doesn't work if you want support role to be able to have credentials access, right? Then you couldn't solve it by just using like a permissions boundary. Then what you would need to do is make sure that this guy cannot assume this role, because the role should have the permissions, and you don't want him to have the permissions, so you need to cut it at basically the attack path at this point, so that the user never gets to be the support role. Yeah, let's have a look at this. So we are in the best case like similar to Wiz, like we are very, very focused on IAM. So one question maybe to give the context is,
Sure. Let me go ahead and project it so people can see it.
Wiz does show an account or role with excessive permissions. CodeShield works similar to Wiz, also do graphs. What makes CodeShield different? So we are very much focused on IAM. So Wiz is also like, we also have like graph-based solution, and we also have like similar things in the graph as Wiz, but from my experience, Wiz doesn't do the policy evaluation in that detail as we do, right? So looking really at this policy pipeline where you have to look at identity-based policies versus resource-based policies, permission boundaries, SCPs, and so on, and the all conditions to really effectively decide if something is possible. So our graph really also models for each resource what can be accessed by that resource after doing the policy evaluation. So do I have an example here? Let's look. No, but what we can see, for example, here in the graph is the secret. That's a demo flag. That's by default not accessible, right? But after doing the privilege escalation, we saw that the attacker is actually able to access it. But generally speaking, rather than using like the graph, you can filter it, you can search it, and so on. I usually say for larger accounts, make sure to use the inventory. This also allows you to look at all the resources in your account and find out who can access it. For example, you could look at this bucket. Who has access to this bucket? Oh, Christophe demo has access. These are the effective actions after doing the policy evaluation, right? Or like, who's admin in my account? Do we have an admin here? See, administrator access attached to AWS administrator access role. Christophe demo is an admin. Lab is an admin. You can answer things like that. So in that kind, it has a similar approach as Wiz. It's graph-based, right? But the focus is much more on IAM. And from my experience, Wiz cannot do like these privilege escalation detection, and that's in that precision, and with gaining like that knowledge about the impact to really prioritize what you should focus on. Anyways, we are quite far in time, I think. So is there another question?
There is, if you don't mind, if you've got the time here, we've got a few more minutes. I'm gonna go ahead and project it so we can talk about it. But there's a question that came in from Tony that says, does AWS log the source IP address for any attempt for the AWS STS get caller identity? Asking to see if we can alert to know when someone is trying to run this outside of a known region or of an IP address. So STS get caller identity is an interesting topic because unless you're running a very small account, let's say, for example, it's just your own personal sandbox account, in which case you only use it a little bit, or you're not going to run that command that frequently, then in that case, yes, you could try to do something like this where you alert for when that call is being made. But if you're in a larger type of organization or environment, that usually turns into a disaster pretty quickly because a lot of people are going to be running that command, especially when you have a lot of different roles that you're assuming. You authenticate and then you're like, wait, which account am I in again? which role am I using, and so on. As you go throughout the day, like you may have hundreds of these calls happening per day. So if you have some sort of alerting on it, then that can get very, very hectic very quickly. But just to demonstrate it, you are able to do that. So let me go, if you don't mind stopping your share screen so I can take over and share mine. You are able to see the call in CloudTrail, for example, and then you're able to look at things like the IP address. And let's go ahead and launch this. Are you able to see this?
I can see it now, yes.
Okay. So yeah, in this case, we could see, this is the username, get caller identity is the event name, STS is the event source. You have the IP address, things like that. And you can see the exact record. So you can see who made it, when they made it, things like that. Now, if you have some sort of filtering, maybe for the IP address, so say that all your employees are in North America, and then out of nowhere you have a request like this coming from Russia, as long as you have something that can ingest the CloudTrail data and filter for that and have that logic behind the scenes, then technically you could do something like that. But if you have global accounts, or if you're a global organization, that's going to be pretty tricky. If you've got people in 20 different countries, that may not be as feasible. Also, keep in mind, attackers can use VPNs. So if they know you're based primarily in North America and they're in Russia, they could use a North America VPN. They look like they're coming from North America. So not as helpful there. There's also this event here, just so you can see it, for the put role policy call. So in this case, we have the event name of put role policy and event source of IAM. And again, we get to see who made it, for what they uploaded. A lot of the information that we were able to see in CodeShield, this is more raw data. You can't look at this and quickly see, here's what's going on, here's what this is linked to. Even the policy document, super hard to read. So typically, this is your source of truth, and then you ingest that somewhere else, or you use something like CodeShield that already creates all those connections behind the scenes for you, and then you create alerts around that. Like if you are particularly sensitive to put role policy, then you could create alerts around that if you wanted to. But again, in large organizations, this could happen on a daily basis, and then you might get flooded with a lot of noise. So something to keep in mind. All right, but that was hopefully that answered your question. I think we've got one more question about CodeShield here coming up, Manuel, if you'd like to answer that one.
Yeah, okay. What level of access does CodeShield need for your account? So how we usually do this, like we connect with the AWS CloudFormation wizard. So you will just like deploy a small CloudFormation template in your account, which contains a role that we can assume to conduct the analysis. And this role allows us to get like meta information of the accounts. We don't have any write permissions or so on. We cannot change anything in the account. We cannot like read databases or read S3 bucket contents. What we can do is we can like list and name everything, like which Lambda function do you have in your account, which S3 buckets, what are their permissions, give me all IAM users, right? So only metadata and basically the permission setups. Is it possible to schedule scan, for example, every day at 11 p.m.? Yes. So what we propose basically is either you do like periodic scan, like every day, every week, every 2 days. You can configure that freely, or you have like we have an API. You can just trigger the scans as well. So we have like customers who like after the CI has run through and deployed the environment, it will just trigger the tool to do a scan and then with a webhook report back, right? So these are the more automation we propose basically.
And since we are running out of time, let's go ahead and wrap up quickly here. I'll share back my screen. Just a little bit of, oops, there we go. Just a little bit of more information about CodeShield. So if you're interested in checking it out, there's information here. Again, these slides will be sent out, so you're able to click on the links if you'd like to. I know there's also the email down there, Manuel. I think that email format got a little bit messed up, but you can also email Manuel at, I believe it's manuel@codeshield.io, right?
Yes, that's correct.
Perfect. And then if you are interested in AWS cloud security training, please check out cybr.com, cybr.com. We have a lot more labs like the one that I presented today, anywhere from AWS IAM Privilege Escalation all the way to even incident response, where we look at using CloudTrail, Athena, CloudTrail Lake, things like that. So if you're interested in learning more about AWS security, that's your place to go. Here are some of the resource links that will be sent out afterwards that show the lab that was used, the CodeShield website, and the IAM Privilege platform. And then if you'd like to connect with us on LinkedIn, if you have any follow-up questions that we didn't get to answer today or any more information you'd like to get from us, go ahead and connect with us on LinkedIn. I'm pretty active on there. I know you're also very active on there, Manuel. And then also we have some upcoming webinars. So you can see them in the bottom right corner if you go to cybr.com/webinars. If you're studying for your AWS Certified Security Specialty certification, it's a mouthful, we have a study group that's happening and starting this week, and you can register for it for free on that page there at cybr.com/webinars. So check that out. Manuel, anything else you wanted to add before we wrap up?
No, happy to be here. Just general stuff, right? It was a lot of fun. I love that we had so many questions. I can also stick around like 5 or 10 minutes more if there are more questions, but currently there's nothing new I can see.
Yeah, definitely. And sometimes some of those questions, it's like, I want to ask in private. That's totally fair. So if that's the case, then you can DM Manuel directly on LinkedIn or even via that email.
Yes, you can. Yes, exactly. And in the slides, there's like a link to the email, but also there's like the schedule a demo button where you can directly make an appointment with me. Whatever you like, right? What we usually propose is like you can either, it's software as a service, it has like a free model, so you can just set it up yourself, try it for yourself. But if you want to, you can also book a call with me, and we go over the results. I help with like how to fix this, how to prioritize, and how to understand the findings just for free. And generally speaking, from setting up the account to having like the scan results doesn't take more than 30 minutes. So I just suggest to try it out if you're interested.
And there's a comment that came through saying it was the first time joining and they learned a lot. That's awesome. I love to hear that. That makes it worth it. And so thank you for sharing that. And also we do these fairly regularly. I think right now we're doing maybe 1 to 2 a month. Different topics, not always IAM privilege escalation. Sometimes it's more defensive, sometimes it's more offensive, but it's always related to cloud security, either getting certifications or actual practical stuff like we learned today. So the best way is to go on that page, to subscribe to the newsletter, to follow me on LinkedIn, or even to join our Discord at cybr.com/Discord, because that's the best way for me to push out, hey, there's a new upcoming webinar in the next few weeks or whatever. Here's where you can go to register for that. They're always free. So it's definitely worth checking out if you enjoyed today's session and if you want to see more sessions like this. But otherwise, thanks everybody for attending. I'm glad to see we had so many first timers today. Hopefully you all enjoyed it. And Manuel, thanks so much for coming back a second time. I enjoyed the first time. I enjoyed the second time as well. So maybe we can do this again sometime. Thank you so much.
Same for me. Thanks for the invitation.
Absolutely. We'll see you later.
See you.
Take care. Bye-bye.